Hello and welcome to Diplomatic Derivatives. In today's video, we'll be continuing with our permutation and symmetric group series, where we have already uploaded part 1, in which we have explained in detail the basics of permutation, what is a permutation, equality of permutation, identity permutation, as well as product of permutation. So make sure you check that video out to clear your concepts. The link is in the description box below as well as in the I button above. Make sure you check that out before continuing, so that is easier for you to get the grasp of the next concepts. In this video, part 2, we'll be talking about cyclic permutation or cycles, length and order of a cycle, inverse of cycle, disjoint cycle, and the product of disjoint cycle. So this is also a very important video to clear your concepts. So let's see what is cyclic permutation. A permutation of a set S is a cyclic permutation or a cycle if a finite subset A1, A2 to AN of S such that the permutation A1 will be equal to A2, A2 will be equal to A3, and so on till AN equals A. So what does a cycle basically mean? This is the general definition. Okay, we have this subset, okay, which is finite. So you don't have infinite number of elements, it's finite number of elements. All right, and let's suppose that is named S. Okay, now it will have either S1, S2, S3 number of elements. Okay, so if it's S3, let's suppose, so your permutation will have 1, 2, 3 on top. Okay, and then depending on the cycle, you will have here 2, 3, and 1. Okay, this we have already seen in the previous video how to write this. So again, I'm saying make sure you check that out to understand what's happening here. Okay, so basically for a finite set, so it could be either S1, S2, S3, S4, and so on till n. Okay, that's why it said AN, because it's going to stop at some element. Okay, so what is happening basically, that each element is mapping on another element. So the image of one, let's suppose if you look at this example, you have 1, 2, 3, 4. So this is for S4. It's for a group S4. All right, and each element is mapped to another element from the set itself. Okay, not another different element, it's from the set itself. Also, again, in the previous video I explained that there is no repetition or there is no leaving out of any element. So 1 is mapped on 2. So let's suppose if this 1 is A1, it's mapped on A2. Then A2 is mapped on A3, A3 mapped on A4, A4 mapped on A1. Okay, that's how you will get a cycle. So how you will write it: 1 goes to 2. I'm giving a quick recap of what we did in the previous video. 1 goes to 2, so you write 1, 2. Then 2 will go to 3, you write 3. Then 3 goes to 4, you write 4. And then 4 goes to 1. So cycle completes, therefore that's where you stop. So your first, this thing over here that you get is called a cycle. All right. Now, one thing to note here is, if the permutation X goes to X itself, and X is element of S, then X will not be an element of this cycle. Okay, for example, if you get F of 3, okay, let's suppose if you take 3, look at this example. You have 1 goes to 2, 2 goes to, it's not 1 here, it's 4. Okay, so 1 goes to 2, you write 1, 2. Then 2 goes to 4, you write 2, 4. And then 4 goes to 1, so the cycle completes. But where is 3? You don't see 3, right? Because 3 goes to 3 itself. This is a cycle of this permutation group, which is S4, because there are 4 elements. Okay, so it's S4. For S4, this is one of the cycle. Okay, but it does not contain 3. So it's not necessary that each element of this group will be part of every cycle. No. A group will have multiple cycles, but all elements will not be used in all the cycles. Okay, this is just one example where all the elements are used in the cycle. When I say that there is no repetition and no rewriting of any element, it means that it's in this permutation, not in the cycle. Okay, all the elements must be present in the permutation. Okay, for example, here all the elements are present in this image permutation. All right, 3 goes to 3 is seen here, all elements are seen, but inside the cycle you won't write 3 because 3 is an image of itself, so it will not be represented in this cycle. All right, so this is what this means here, that f of 3 is equal to 3. The image of 3 is 3 itself, therefore it's not written in the cycle. 3 will not be element of this cycle. All right, so then we write the permutation as this. So this is basically an understanding of a cyclic permutation. We'll be performing examples and theorems, and it will be much easier for you to do in that case. All right. Now, length of a cycle, again a very simple concept. The number of elements in cycle is called length of cycle. So for this particular cycle, the number of elements is 4. So the length of cycle is 4. All right. If the length of cycle is r, it is called r cycle. So this is a 4 cycle. If the length of elements is 3, then it's a 3 cycle. And length of identity permutation is it's 1. Okay. What is an identity permutation? We have explained in the previous video. Identity permutation, that is something in which all elements are mapped to themselves. So it will be, if it's 1, 2, 3, okay, so 1 will go to 1, 2 will go to 2, and 3 will go to 3. So a cycle for this is length will be 1. Each element is going to itself. All right. Next we have order of a cycle, means how many times do we multiply a cycle that we get an identity cycle. So what does this mean? This means that, let's suppose you have the cycle which is from S6, okay, that because there are 6 elements, 1, 2, 3, 4, 5, 6. Now 1 goes to 1, so it's going on itself, we will not talk about it, okay, just omit it. 2 goes to 4, so this is the first thing that you are going to use, okay. This is why I'm saying this, because 1 is already going to 1. 1 will go to 1 if we are doing it 1 into 1 is going to 1, 1 into 1 3 times going to 1, 4 times going to 1, because it's mapped on itself, okay. We have 2 goes to 4. So let's suppose we write here the image of 2 is 4. Now what you are going to do is you're going to multiply it with itself. So for this thing you're going to take another permutation. So what you do is, for image of 2 is 4, then image of the image of 2. Image of 2 is 4. In place of this you will write 4. Okay, this thing will become 4. Then the image of 4 is what? It's 5, right? So this is what you get, 5. Then this means that image of 2 times, you did 2 times, right? So you get 5. Then if you do it 3 times, you will get 6. You can perform and see, right? Because after this, if you perform an image on this, image of 2 square, image square of 2 is what? Is 5. So in place of this, you'll write 5. So image of 5 will then become, what is the image of 5 over here? Image of 5 over here is 6, right? So what do you get? You get 6. Then do it 4 times. Then image of 6 is what? Image of 6 is 2, right? So image 4 times of 2 will give you 2, right? This is where we stop. Now we know that when are we getting identity? What does it mean by identity? That the element goes to itself, right? Like 1 goes to 1 itself. Now 2 will go to 2 itself after how many times you perform the operation? You perform it 4 times. Similarly, when you do it for 4, 4 goes to 5, then 5 goes to 6, then 6 goes to 2, and 2 goes to 4. How many times will you perform it that you get the same number? You get 5. You perform it 4 times. Then for 4 also you perform it 4 times. 6 also you perform it 4 times. All of these, when you perform 4 times, you get the same identity, right? For 1 and 3, obviously they are going to itself, right? But for the rest of them, when you perform it 4 times, you're getting the same element. Therefore, the order of the cycle itself is 4. Okay, this is how you are performing to understand what is the order of cycle. But there is a very much easier method as well, which is A length of a cycle is the order of the cycle. So whatever is the length of a cycle, automatically that's the order of a cycle. Another way of doing it. Okay, this is why did I explain this? To make you understand the concept that how many times will you perform this image operation on the element that you get the identity. That is the number of times you perform the operation is the order. Okay, normally when you look at a cycle, you see this is the length of the cycle, therefore this is the order of the cycle. So length of the cycle, this is a 3 cycle, so its order is 3. Okay, inverse of a cycle is again another simple concept. Just you have permutation is equal to 2 4 3 5, so the inverse will be the opposite, so it will be 5 3 4 2. That's the inverse. Disjoint cycle, two cycles are said to be disjoint if they have no common elements. For example, you're talking about S5, okay, that is 1 2 3 4 5 are the elements. Okay, and when you find the number of cycles inside S5, how do you know how many cycles are there inside a particular symmetric group? So what you do is, which will again be explained in future videos, 5, because you have S5, so you take 5 factorial. Okay, 5 factorial is what? 1 into 2 into 3 into 4 into 5, which is 120. So the number of cycles inside S5 is 120. All right. Out of those 120 cycles, one of the cycle is 1 2 4 and another cycle is 3 5. Okay, out of those 120 cycles, you have these two cycles. These two do not have any common elements. Therefore, these two cycles are disjoint. Okay. Now, what is the product of disjoint cycle? Again, very simple concept. So what you do is, for example, if you have one of the cycle is 3 4 6, one of the cycle is 1 2 5. So these two cycles are part of S6. It means that how many numbers are going to be there? 1 2 3 4 5 6 for each of these. Okay, these two are part of this symmetric group. These are the cycles of symmetric group S6. All right, so how do you write these? Row will be written, row is 1 2 5. So when you have to convert it from this step to this step, which I have explained in the previous video, how do you do that? 1 to 5 will be written as, first you write 1 2 3 4 5 6 as it is. 1 goes to 2, so you will write 2 here. Then 2 goes to 5, so you will write 5. 3 is not mentioned, so 3 as it is. 4 again not mentioned, as it is. 5 will go to 1, so 5 goes to 1. 6 is not mentioned, so 6 as it is. So that's how you get the first permutation. Then this one 3 4 6 will be written as, again, 1 is not mentioned, 2 is not mentioned, 3 goes to 4, 4 goes to 6, and 5 is not mentioned, 6 goes to 3. So that's how you will write that. And how do you find the product? If you have A dot B, for example, if you're finding A dot B, so first you will write B and then you will write A. Okay. Similarly, if you're writing B dot A, so first you will write A and then you will write B. Okay, that's how you multiply the permutations or find the product of permutations. Okay, and then that's how you're going to solve it. So the answer will be 1 2 3 4 5 6, and then what you will do is 1 goes to 2, 2 goes to 2, you write 2 here, 2 goes to 5, 5 goes to 5, then 3 goes to 3, 3 goes to 4, 4 goes to 4, 4 goes to 6, 5 goes to 1, 1 goes to 1, and 6 goes to 6, 6 goes to 3. So that's how you get the answers. Check out the previous video. It will be much easier for you to understand how we got this. If you still have doubts, make sure you write it down in the comment box below so that I will be able to create a I will be able to help you out with other examples so that it's easier for you. This implies that when sorry, one mistake over here. This, okay, yeah, it's not a mistake. I just didn't write that part. So if you what you found here, if you multiply this permutation with this permutation in one direction, if you do it in the opposite direction, you're going to get the same answer. So both sides are equal. Okay, every permutation can be expressed as a product of disjoint cycle. What does this mean? If you have a permutation, you can write it in the form of a product of two disjoint cycles. Disjoint cycles are cycles that do not have common elements. Okay, so if you look at this permutation, let's suppose you have 1 2 2 1 3 4 4 5 5 6 6 3. How do you write it? First 1 goes to 2, 2 goes to 1, so that's 1 2. When 2 goes to 1, cycle ends, right? So It's just 1 2. It's not continuing. Okay, then you have the next cycle, 3 4, 3 goes to 4, 4 goes to 5, then 5 goes to 6, and 6 goes to 3. So it continues. That's how you stop the second cycle. So what you see here, that you have two cycles that are product of two disjoint cycles, and this is the permutation. So basically what you did is you wrote this permutation as a product of two disjoint cycles. All right, so this is how you perform the multiplication or the product of two cycles, and how do you write a permutation in the form of disjoint cycles. All right, so order of permutation for disjoint cycles. For the disjoint cycles, let's suppose in how we saw in the previous example that we got two disjoint cycles, right? We have to find the order of the permutation for disjoint cycles. So when you have these two disjoint cycles given to you, from these two cycles you have to find the order of the permutation from which these two cycles came. Okay, how do you do that? That's the LCM of the length of the disjoint cycle. So what does that mean? That LCM of, what is the length of this cycle? 2. What is the length of this cycle? 4. So LCM of 2 comma 4. What is the LCM of 2 and 4? It's 4, right? So the order of the permutation will be 4. All right, so this is how you will write the order permutation from disjoint cycles. All right, so I hope it was clear. I tried my best to make it as simple as I can for in order for you to understand the concepts. If you have any question, make sure you ask me in the comment box. I'll try my best to solve them. Make sure you like, share, and subscribe to my channel so that I can make much more complex topics simpler for you. And in the next video, we'll be talking about permutation symmetric groups part 3, where we'll be touching more complex topics as well as starting the theorems that will come in the examination. So make sure you watch out for that video. That's all for today. Thank you. Bye bye.